A body was found behind home called in by the owner. With the search warrant secured, you enter the home only to be hit by the strong smell of chemical cleaners. With no other evidence present, detectives turn to a last-ditch effort.
Luminol.
When electrons are in an excited state, they jump to the outermost orbitals due to excess energy. However, the excited state is very unstable. So, they release the energy in the form of photons to jump down to the lowermost orbital, called ground state. But how does this apply to forensics? Luminol is a powdery compound made of nitrogen, hydrogen, carbon, and oxygen. It is dissolved in sodium hydroxide. Additionally, hydrogen peroxide, an oxidizing agent, is mixed in along with water and is the basis of the chemical reaction. The chemical reaction starts with luminol going through a process called deprotonation. Deprotonation is the loss of a proton in an atom, ion, or molecule, which results in a conjugate base. In this process, a molecule becomes a nucleophile, which just means it has an extra electron pair that can be shared. Translating this to luminol, it reacts with the hydroxide ions and loses 2 hydrogen ions to form a dianion, an unstable dianion. In seek of stability, there's a rearrangement in the electrons called tautomerization. Simultaneously, hydrogen peroxide decomposes into water, releasing oxygen in the process. Oxygen reacts with the dianion to form 3-aminophthalate, an unstable compound that exists in an excited state.
Keep in mind, I've had to simplify this reaction a lot, but I would like to expand on the formation of 3-APA. With the addition of oxygen,
nitrogen atoms break off, releasing nitrogen gas. Following the release of nitrogen, it forms an unstable intermediate endoperoxide. The bond between the bottom 2 oxygen molecules weakens and stretches. This gradually increases the energy in the molecule. It's important to note that because of this, the molecule exists in a triplet state. In pursuit of stability, 3-APA in its excited triplet state performs an intersystem crossing to become a singlet state. From there,
when the bond breaks, the electrons return back to their lowermost orbital, releasing photons in the process.
Photons are responsible for the soft glow. Phew! That was a lot. But we're not done yet. This chemical reaction is actually very slow, but that's not a bad thing because that's where forensics comes in. Blood contains a protein called the hemoglobin. It transports oxygen to the other parts of the body. The iron in the hemoglobin is a catalyst for this chemical reaction. The hydrogen peroxide in the luminol solution reacts with the iron in our blood to rapidly produce oxygen molecules. This chemical reaction is faster because of oxidation. However, this reaction hardly lasts for 30 seconds, so forensic investigators have to act quickly to capture the scene. But even if a killer cleans the crime scene, luminol can still detect the blood. Luminol detects both aged blood and diluted blood. Thanks for watching. Bye!